Hi, this is Kevin Trainer, and welcome to the third tutorial associated with Chapter 2 of the Zelle textbook, third edition. And in this one, we're going to be creating a program called kilometers to miles. It's the classic conversion calculator. And here's the reason that we're doing it. In this chapter, we're really trying to explore the pattern of input, process, output. And the classic conversion calculator has some work to do on all three parts. Okay, and the couple things we did before this, we had some parts that were missing, or we were simulating them. Okay. So the file is called kilometers to miles. It's a program that should be converts, not converse, converts a measurement in kilometers to a measurement in miles. And I've already looked up the conversion factor. Where do I get these? I typically get them off the web. Let's hope they're reliable here. In the problem that I give you, that's a parallel problem, I give you the conversion factor to use. So I say here, note conversion factor is 1 kilometer to 0.62137 miles. So that's how I came up with that. So again, in keeping with the other tutorial examples that I did, I'm starting out with pseudocode, and it's not going to be too surprising when I copy over my pseudocode for my pre-baked version that my pseudocode has got three parts: get input, do processing, create output. Okay, because we got some work to do for all three. So let's go down and get ourselves, ooh, that was the wrong line. Let's go down here and get ourselves a main function, def main. Okay, and let's copy down some pseudocode. So let's copy down the get input. That didn't work. Let's undo that. So I really want to copy that. So I always like things to be indented about the right way. So I'm going to do that, and I'm going to make a comment, and I'm going to have a space. So I'm going to say get input. And I think I indented that too far. I think I only wanted it that far. Okay. Okay. So get input. Now, so I want to prompt the user in a polite way to give me kilometers. And again, I don't want you watching me typing because I don't think that's a good use of our time. So here's my code for that. Okay, so I have an assignment statement, and the variable is kilometers. I think that's just wordy enough. Okay. Pretty clear what I mean by that. And on the right side, I have a prompt on the inside, so I have an input with a polite prompt. Please enter measurement in kilometers, colon, space, because I don't want to be typing right up against that colon when I'm doing the input. And in this case, because I'm expecting to get a number back, I am going to have to use eval. This is the last time we're going to be using eval, because in the next chapter we're going to replace it with things that are not as hackable as eval. But eval is fine for this one. Okay, so we're going to evaluate that string that we get back that is a number of kilometers. And then we're going to assign that value, that number value, to the variable kilometers. Okay, so that's the input. Okay, so let's do the next part. I'm going to copy over both the pseudocode and the real code. and it looks like this. So to do the processing, we're just going to do in a typical conversion calculator. You just do the conversion with the math. So we say miles, it gets assigned kilometers times the star, and then we use that factor we had up there before, is 0.62137. Okay, so that's the processing. And now let's just do the output. This is going to be pretty simple too. Okay, so let's go down here and do the output. So the pseudocode is create output, and the real code is print measurement in miles, colon, no space, comma, miles. Why no space? Well, you'll remember that when we're printing, when we separate these either variables or literals with commas, we get a space automatically between the items. So we don't have to add a space if we're going to get one automatically. Okay, that looks good. So to run it, we're going to need to invoke main. So let's go down and do that. Main, paren. Okay, how's that look? Yeah, that looks good. And I always do a Command S on my Mac to save it, because I'm a doubter. You don't really need to do it, but for some reason I do it. So let's do a test. So we want to right click and say we want to run kilometers to miles. And here we are down here. Let me scroll this up a little bit big. So enter the measurement in kilometers. So when I think of the kind of testing I want to do, I want to make it easy to see if the general math is working. So I'll just put in 1. Okay. Okay, and what did I get back? Measurement in miles, 0.62137. Well, that's our factor. That's great. Okay. Now I'm thinking, well, if I've got 10 miles, I should get something that looks like 10 times this. So it would be something like 6.2137. So let's see what happens if we do that. Let's go over and say we want to run again and make this a little bigger so you can see it, and put in a 10. Okay, and this is where we see that floating point arithmetic in Python can be kind of disappointing, because what we have here is an approximation. So instead of 0.2137, we get 2136999999. Now we're going to learn how to control both this value, if we want to round the value, or the display of the value, if we just want to control the decimal places in the output and not change the underlying value. But we're going to learn how to do that in another chapter. So this is just fine, okay? And it's an artifact of rounding of floating point numbers in Python, which happens in pretty much every modern programming language. Okay? We also wanted to do a little bit of other testing. What if we gave it a 0? This is where you begin to see what could the user reasonably input and get a reasonable answer. Okay, so let's what if the user put in a 0? Would we get a sensible answer back? 0 measurement of miles, 0.0. Yeah, that's a sensible answer. So that's good. What if they put in a negative value? Okay, can we think of negative kilometers? Well, if we're talking about going one direction or the other, like north or south, maybe southern kilometers are negative. So I'd like to be able to support that. So let's run it again, and let's see if we put in a -1. What do we get? And we get a negative value. Well, again, we're getting a sensible output for what is pretty reasonable input. Now, something we haven't explored before is what happens if the user really doesn't cooperate at all. They don't give us any kind of a number. Oh, you know what we haven't tested yet? Let's test before that. What if they give us something with a decimal point? For instance, what if they give us 1.0? Well, it gave us a reasonable answer. So it's able to handle a decimal point. Okay, that's great. That's a pretty robust program. Okay, what about a blatant disregard for giving us a measurement in numbers? And what if they said, "Hi, Mom"? What would we get? Kaboom. Okay, so we get syntax error, invalid syntax. So in these early days, okay, we're trusting the user to give us the input the way we're trusting the user to follow the rules. In the long term, we're going to learn to be less trusting. Okay. So in the very long term, before we're finished with the course, if we ask the user to give us a number, we'll check. We'll make sure that if they don't give us a number, that we might terminate the program immediately, or we might reprompt again. But whatever we do, it's not going to have this kind of ugly ending. Where we're getting a lot of Python error messages. But again, for right now, like the rounding that we saw before, for right now, with what we know right now, this is fine. If they give us an unreasonable input, we'll give them an impolite output. That's okay. All right, so you're going to do something pretty similar to this as your assignment. And I'm going to say bye until next time. Bye-bye.